Now you do, right? Everybody, do you guys see my screen?
Yes.
Okay. So relations. So relations and functions, not exactly the same thing. So you're gonna first define a relation, then we're gonna see what's a function and what's the difference between them. They're related, but they're not the same. To understand the concept of relations, pretty simple. It's basically when you have a table, for example, with basically, for example, names and age of students. So we have a table here with 2 columns and multiple rows, as many as the students. So let's say take just a few rows here, maybe 3. Okay, so let's say first student's name is A, the other student's name is B, and then C. So each student from here has an age, whatever that age might be. You just randomly say age of this student is X, this one is also X, and this last one may be Y. Okay, so that's a relation. Why? Because basically these 2 columns are not random, they are related. They form a relation, hence the word relation. Okay, the data here on this column corresponds or is related to the data on the other column. So a table is basically a relation. We can actually write each row by itself. So this is a row or a line. Okay, row, another row, another row, and these are columns. So each row represents what we call an ordered pair. For example, student whose name is A, their age is X. That's what we call an ordered pair. Okay, it's an ordered pair. It's not random, it's ordered. It's related based on this table. So ordered pair. Pair simply because it has a pair of values, value A, value X. What is the next ordered pair in this table? What is it?
B and X.
That's right, B and X. Student B, his age is also X. And finally, the third one,
C and Y.
C and Y. Okay, so all these are ordered pairs. Each one of them
Is
is
younger.
that's right. So basically, this is just another way of writing this table. Table could be like this, or it could be an ordered pair. The same data is presented in 2 different forms, or it might even be presented as a graph. We're gonna talk about graphs a little later. So that's basically what an intro to relations. The table may have infinitely many, I don't know, many columns, but also rows. So depending on how much data, what exactly you're trying to keep track of. If this was, for example, the names of all the people in the United States and their age, so there's gonna be a huge table with millions of rows or records and many columns, maybe other than name, age, address, phone, whatever, social security. So that's basically how databases work. If you heard of the word database, just a base or a repository with a lot of data in it. Data on anything, data on people and animals, or on the environment, whatever it is. So we keep track of all the data in tables, one table or more, usually many, many tables related to each other, and we call that a database. So a base of data, repository, where we store and put a lot of information to be able to be retrieved later for different use whenever we need it. So that's the introduction to a relation. Now, how do we tell whether a relation, what's the relationship between a relation and the function? So that's another issue we have with the relations and functions. They're not exactly the same. But before we see the difference between functions and relations, so this basically here, what we call ordered pairs, we can easily transform this into some set like this. So we say set, give it a name, for example, students, then you do a colon, And then you include all the pairs in what we call curly braces. These are not parentheses, they're not brackets, they are curly braces. Okay? That's a curly brace, not a bracket, not a parenthesis like this. Okay, so that's what we call set, notation. Okay, set notation is simply, again, you need a name, then colon, 2 points, open the curly braces, and you list all the elements of that set. Again, it could be animals, could be people, could be vegetables, whatever. So element 1, comma, element 2. So you need commas here between these two elements. And element 3, and so on. Then you close the curly brace. So this could be anything here. All the elements are separated with commas inside. Don't forget the colon and the name of the set. The name is usually meaningful based on what you have. For example, here vegetables, whatever it is. As you can see, each student has an age. Okay, these students happen to have the same age, which is fine. Okay, but can one student have 2 ages, for example? Can student B have age X and age Y?
No. Yeah. No.
It's impossible. That's
Yeah.
Function, the difference between a function and a relation. So a student cannot have 2 ages. So basically, a function has to be one element from the right should correspond to exactly one element from the left. That's what a function is. If not, it would be just a relation, not a function. So a function, let's actually write the definition. Let's call this number 2. Function. So A, B, C. So exactly each value corresponds to one value. So each element from the left column your mic if you have background noise. Left column corresponds to one element or value from the left one or from the right one. Okay, so again, each element from the left has to have exactly 1. You can't find a student with 2 ages or 2 social securities, so it has to be 1. 1 from here has to have exactly 1. But 1 from here, 1 student from here can share, or 2 students from here can share the same age, which is fine. But 1 student cannot have 2 ages. So that's basically how you tell the difference between a function and a relation. If each element from the left has exactly 1 value from the right, then it's a function. If not, it's just a relation. Let's do a couple examples here. We'll see if that makes sense. So let's say DFG. You guys tell me whether this is a function or not. Let's say 1, 5, and 7. So let's say this, then say this, and this. That's a relation. Everything is a relation, okay, by default. Some of them are strict. They're one-to-one, they're functions. Is this a function or not?
No,
Okay, can you explain why?
because the F goes to 5 and 7.
That's right. So this is against the definition. Each element from the left must have only 1 element from the right. But this element breaks that rule. This element has 2. This element has 2, so that makes it not a function. Okay, just a relation. Okay, everything is each table is a relation, but some of them are functions. Just a relation. All right, let me give you another example. X, Y, Z. And then we have 4, 5, maybe 7 here. Actually, let me take only 2 values like that. So that's a relation, if you put it as a table. Is this relation a function or not? In other words, does each element from the left have one element from the right?
No,
Why not?
because I see here X, Y is 4.
We're gonna check from here, not from this side. Check from here. Does this one have exactly one element? X itself, does it have exactly one element from the right? Yes.
Yeah.
So X is only related to 4, that's it. Is Y, does it also have only one element from the right? The Y here. How many Y values does Y have? From this side?
1.
Just 1, that's right. 1 from here. And Z, how many values? It has 1.
1.
Okay, so this is not okay, but this is okay. So think about it this way. One student cannot have 2 of anything, especially the things that uniquely identifies a person or something. For example, cannot have two ages, 2 social securities, but it could have 2 objects that do not necessarily uniquely identify human beings. For example, this student might have 2 phones or 2 cars, but they cannot have one of the elements that uniquely identify humans, like social security or sometimes not necessarily name. People can have the same name, but especially the social security, people cannot, one person cannot have 2 numbers. But if you see it this way, think about it as 2 students having the same age. Is that okay for 2 students to have the same age? That's okay, right? That's fine.
Yes.
Okay. So a student can have the same age, but one student cannot have 2 of these. So so understand this. So this is, if it's this way or more, this is not a function. If it's the other way, that's fine. If it's the other way, one student cannot have 3 ages, but 3 students here can have the same age. For example, I don't know, 20 here, all the same thing. So that's the concept or the difference between functions and relation. Don't worry if it doesn't make sense yet. We're going to do a few examples. And let's see, 1, 2, 5, 4, and 7. And again, I'm going to do this. Okay, maybe this, and okay, so we said this one is a function. Okay, is a function. What about the next one? Is it a function?
No.
It's not a function. What makes this not a function?
The A has both 1 and 2.
That's right. One element has 2. It can't be that way. Each one from here must have exactly 1. X has exactly 1. Y has exactly 1, and so on. So not a function. One more example, X, Y, Z, and let's say, I don't know, some number here. Some random relation, whatever it is. Is this a function or not?
Yes.
No, it is.
Yes, it's a
Why do you
function.
say no? Always I can check it against the definition. Does each element from here have exactly one element from the
Oh,
other?
I see what you're saying. It's one number only. Okay.
That's right.
Yes.
Okay,
Yes.
so X has exactly 1, not a problem. Y has exactly 1. C has exactly 1. So in other words, 3 students may have the same age. That's fine. But one student, for example, here cannot have 2 ages. Okay, so this is not okay, not a function. This is okay. This is a function. Example, this is a function here. Okay, let's try to write these, a couple of these in set notation. So set notation again is this. You have a name for a set or group, for example, people, and then you say this name and that, or I don't know, vegetables. You say the name of the group is a group of vegetables, and then you list all the vegetables separated with commas. So let's write these in set notation. So set notation. This one, let's call this whatever set it is, set 1, for example. What follows the name specifically? What comes right after the name in the set notation? We need, what do we call those? Colon, okay? Those 2 points are colon. Sometimes it's like this. This is semi or semicolon, but this is a colon with 2 points. Then we open the curly brace, okay? The curly brace, not parentheses, not brackets. And we list all the elements. Okay, give me all the ordered pairs of this one. All the ordered pairs like this. What's the first one here for this one?
D1.
That's right, D1. So the ordered pairs must be in parentheses. That's the first element. Then comma. Okay, don't forget to separate your elements with a comma. What's the next pair or element of this set?
F5.
That's right, F comma 5, because F5 are related.
Would you also do F7 next, since it has 2 numbers?
Yeah.
F7, that's right. F also has 7, so we're gonna write that. One final pair is
G7.
7. Someone has background noise. If you could please do something about it. Either turn it down or mute yourself. So this G7. And what's left? So we listed all the elements of the pairs. What do you do now at the end of this?
Close with the
That's right. We're gonna close the curly brace. We open it, we close it. That's done for this. So this says, we said this is not a function, right? Because of the F. F has 2 values. If you had only this, let's say you don't see this, right? You didn't see this, but you're only looking at this. Can you tell from here whether it's a function or not?
yeah.
Okay. Based on what exactly? What makes this not a function? Just by looking at this, not looking at the...
Because F have 2 numbers.
Exactly. So we have F repeated here. So that makes it not a function. If you have repetition here, not a function. It's basically the same as seeing this. So if we give you this, or if we give you a set notation, you can easily see whether it's a function or not. Just look at the first element, not the second one. Make sure this one, if this one is repeated, then not a function. If it's not repeated, then it's a function, as we're going to see with this example here. So let's write this one in set notation and understand that. So this one here, so this is for this. Now let's do this in set notation. So let's call it set 2. Again, right after the name, you need to put colon and open the curly braces and list all the elements or the order pair. What is the first order pair in this relation?
X
So X4,
4
then
Y4
that's right, Y4. What else?
Z5.
5 and close curly.
Exactly, Z5, and all close the parentheses and close the curly brace. But let's say you didn't have this, right? Just by looking at this one, is it a function, or how can you tell it's a function?
Because it's one number to, I'm trying to remember the student thing we use, because it's one. It's,
Which value?
it's 2 students to 1 number,
That's
right?
right. Which value do you look at exactly? Here we look at the first one.
You're looking at the element, not the number.
That's right. So we look at the first value of each pair. That's the only thing we're interested in. So this is X, Y, Z. We say these are distinct. Distinct. What do we mean by distinct? They're unique, okay? Unique, or they don't look like any other thing. Each one has its own value. So these are the distinct elements. Nothing is repeated. So a function. But here, when you have a repetition, not a function, or repeated, repeated first value. We only compare the first values, D, F, and F. If you found that repetition, okay, that means not a function. Okay, and here also, all these are distinct or they're all different, okay? They're not the same, distinct or unique, that makes it a function.
Unique.
So now if you have a shape or a relation or a table like this, you can say whether it's a function or not. Also, if I give you set notation, you can also tell whether it's a function or not easily, okay? Let's do a few more examples. If it doesn't make sense yet, it's gonna make a lot more sense after these examples. Sometimes you just use two groups like these, some values, X, Y, Z. And let's say 4 and 8. We take another one. And for this one, I'm going to use, let's say, 7, 8, and 1. I'm going to say this, this. I'm also going to take a couple of sets. Set 1. Just going to put some values here, 3 and 1. -3 and 7. Then 5 and 8. Also another set. Let me make this an 8. Say 5, 10, -1, 4, okay, here again, if let's say look at the first one here. Is this one a function or not? Again, this is a definition of a function.
Yes.
It
Yes.
is a function. That's right. Each one has exactly one, right?
Yes.
Has one has one. You see this? Two students can have the same age, not a problem. So this is a function. What about this one?
No.
No.
Okay, what exactly makes it not a function?
The C has two values instead of just one.
One student cannot have two birthdays.
Exactly. One student cannot have two ages or two social securities, especially when it comes to items that distinctively or uniquely identify us. So this is not a function. By the way,
That student is gonna have a deportation right away.
exactly, he's gonna run into troubles. If the cops find two IDs in your pocket, you're in trouble. Okay, so this student is in trouble. Okay, we're gonna kick his butt later. Okay, so this is not based on this. This is not a function. Now, another example here. So we have a set. Instead of a table or groups, we use in set notation. Is this relation a function or not? Look at this. Forgot.
Yes.
This is a function. What makes it a function?
None of the first values are the same.
Are repeated or are the same, exactly. So unique, we have 2, -3, 5, all different. So this is good. A function. It means no student has two IDs or two of something. What about the next one? Is this a function or not?
No,
Not a function because
the 5 is repeated twice.
that's right. You have the 5 here and the 5. It's like one student having an ID and another an ID, so not a function. That's your intro to relations and function. By the way, everything is a relation, okay? Everything is a relation, but some of them are consistent, are strict, one-to-one, those what we call functions. And does that make sense to everyone?
Yes.
Very simple concept, nothing too complex. Please let me know, everybody in the room, all of you. If you don't get it yet, please let me know. It's an interesting and it's an important concept to understand about functions and relations. So that's what we call set notation. Let me see. Now we're going to see another form. So when we present information, there are many ways to present information, either as tables, as we saw here, or as set notation, or some groups like these. Can you think of other ways, another way of presenting information? A very common one, and a very nice and easy one to see. Another form of presenting information. If the information, it's not always on graphs, it's not always on tables and sets like this. Sometimes it's presented visually in an easy way. What do we call those elements? What do we call those ways of presenting information? Other than tables and sets. I kind of said it. Think of another way to present information, especially in business and finance. How do you see? Do you see numbers?
Not a graph, right? No, that's
Exactly.
similar to chart.
Yeah, exactly. Graphs. That's probably maybe the best way of presenting information because they're easier to see, easier to read, as opposed to table. This is a small table with 3 rows. Imagine if this was some company or some country who have millions, probably millions of rows. Nobody has probably the mental capacity to read all those lines, millions of them, and make sense of them. That's why we need graphs. Graphs can make sense very easily in a glance or at a glance. You just look at for example, if this graph represented the sales of a company, what do you think about the sales?
Highs.
What's the more appropriate word for that? What happened to the sales, let's say from, I don't know.
Growing.
The sales are growing or going up, that's right? You can see
Going up. Yeah.
it takes,
Or decrease. Increase.
that's right.
Increase.
Sometimes you may fluctuate. Fluctuate is when it goes up and down. For example, this month, June, for example, the sales went down, but they were high here. Then they went back again in maybe July or something. And then went down. So this is what we call fluctuate. This goes up, sometimes goes down. So when you look at a graph like this, again, literally in less than a second, you can understand, you can see what is happening to the cells or the data on that graph. But if this was a table with many, many rows and columns, it will take you minutes, if not hours, to figure out what's going on. That's why we like to present our data as graphs. So we put that in graph to make sense of it easily, to make predictions, and to get up, a whole idea quickly without having to read and go through line by line. So if you're presenting something to your supervisor about the sales of your company or projections, whatever, you won't have time to go through each line with you or through each column with you. You just want an idea in minutes or seconds. So you present this graph, you project this graph in a PowerPoint or something, or a conference, and he gets the idea, or they get the idea very quickly just by looking at your graph. Assuming your graph and your data assuming they are actually done correctly and accurately. So that's intro to graphs and why we need them and use them. They're easy to read, visually, appealing, I would say. That's the reason why we use graphs. Now, speaking of our topic of relations and functions, we're going to see how to tell whether a graph, just by looking at a graph, we're going to tell whether it's a function or not. So let's take a few graphs here. I take this one and another one like this. Probably this one as well. And let me try again to do a circle. Not too bad. Let's say these graphs all have two, what we call axes, okay? Two axes. This is the x-axis or the x-coordinate. This is the y-coordinate. This is a bidimensional graph. It has two axes. It could be 3 dimensions, it could be 1 dimension, but someone is getting bored already. We can hear you. Okay, so where were we? So this is a 2-dimensional graph, x, y, the x-axis, the y-axis. And we can easily tell whether a graph is for a function or not. You do what we call the vertical line test. You do a line, you just visualize or you draw a line through the graph vertically and see how many times that line meets the graph. So how many times, in this case, the vertical line meets our graph?
One.
Once, exactly, just once. That's the key. So if it meets once, that makes it a function. So this is a function. Okay, so this is what we call the vertical line test. Okay, so what this means is, so if I give you a graph and said, is this a function? Simply imagine or draw a graph, vertical line test through the graph, and you see if it meets once, it's a function. Function because it meets once. Let me try to write nicer here. Meets once. By once, we mean this intersection point. The vertical line test meets graph once. Vertical line meets the graph once. Okay, now using the same test, the vertical line test, is this graph a function or not?
Mm,
Is this graph a function or not?
no. Don't know.
Not a function. Why not?
I don't know. I just said that.
Okay, so again, if it meets once, you do the vertical line test. If the vertical line test, the red one, meets the graph only once, it's a function. If not, if it meets more than once, it's not a function. So is this one a function or not?
Yes.
Yes, everybody. What do you think? Everyone, I want to hear from everybody in the room. All 16
Yes.
of you. Give us some ideas. Is this,
Can I say something? It's maybe not passing because I said no. It's not passing. How to say vertical line?
okay?
Is it true or I don't know.
You almost did. Rephrase it. Say it again. What, is it a function or not?
No,
Using the line test. Why not?
because not passing vertical
Okay. You're close. How many times?
one. Twice. I'm sorry.
Twice. So if you do that vertical line test like this,
Yeah, that's the twice.
meets the graph here, meets graph here and here.
Yeah.
We're not talking about the axes or axes. So it meets twice. If it meets more than once, it's not a function. So this meets twice, not a function. Okay, line meets graph twice. Okay, let me recap that again. They give you a graph, so to find out whether it's a function or not, all you have to do is do a vertical line test. If it meets exactly once, anywhere on the graph, if it meets exactly once, then it's a function. If you do the vertical line test and your line, the vertical, it has to be vertical always, not horizontal. If it's vertical, if it meets the graph more than once, in this case 2, that's not a function because it meets twice. Similarly, the third case here, is this a function or not? And why?
Yes,
It is. Why not? Why?
because it's only one. Would you the same like first one? I don't know how to explain. Functional because it's going through and it's only one.
Exactly. So anywhere you do that vertical line, here,
Yeah.
here, here, it's always going to be
I think
once.
no.
Only going to meet once.
Yeah.
If it's once, it's a function.
Mm.
It's a function. Nothing to it. Very simple. Just imagine a line. You don't have to solve. You don't have to graph anything. Just do that line.
Oh, so Professor, so if it's marked a point in one side and a point another dot in the other side is a function. The two dots cannot be on the same thing.
Yeah. So it could be anywhere on this.
But it has to be ons, right? It cannot be twice.
Yeah. If it's more than once, not a function. It has to be exactly once. Okay. So for example, here, anywhere you draw that line, it's not a function. It only meets once. It's a function. If it's 2 or more, not a function. This one is a function because only meets exactly once. What about the third one here? Is this a
Not.
function? Not because
It's meeting 2 times.
twice. So if you do this,
Yeah, 1, 2.
it meets here, also meets here. That's more than once. This is like saying one student has 2 IDs. Here, it's good. One student has exactly 1 ID. Here, it's also like saying one student has 2 IDs. So this is not a function, not a function. Same reason we said earlier here. One student has 2 of something. Okay, or from here with the set notation, one student, for example, has same 2 of the same thing, has 2 values. Okay, everybody, makes sense?
Yeah.
It's very simple to takes a second to decide, so make sure you understand the concept. Nothing too bad, just want to know exactly, do your vertical line test. Please let me know if something is not clear here. We'll do, let me give you some graphs. So, are these. All right, let's start with something like this. And possibly you have 3 graphs here. We don't know if they're functions or not. What do you guys think?
First one is functional. Second one is not. The third one is confusing me. Yeah, I think it's functional too.
This one,
Functional.
okay, it's a function because anywhere you do that vertical line,
Mm.
it only meets this once. So this is our
Yeah. Functional.
when you do it, it only meets once. Function. Well, let's see, just yes. The question said, are these functions? You said yes. What about this one here? Is that a function?
No,
Why not?
has it two or more.
2 or more. So it means more than once, so a bunch of times. So if you do that vertical, So again, this is our graph, not the X and Y axes. So it meets with this one, meets once, twice, 3 times. So definitely not a function. It's like saying one student has 3 IDs or 3 social securities. So that's very bad. Now,
No,
is a graph
no,
because,
he has a 2
right? Exactly.
or more.
Yeah, so it meets twice. Exactly. So this graph is discontinuous. That means it's not continuous graph. All these points are not linked. Only these specific ones are actually, all these pairs, order pairs as we talked earlier, we have 1, 2, 3, 4, 5, 6, 7. We have exactly 7 pairs, which we can write like this, some X and some Y. But these graphs here are continuous. They're basically non-ending graphs. They have no limits. They have infinitely many points. You have so many points here, 1, 2, 3, 4. Basically, there's so many, or infinitely many points. So we can't write all these pairs. It's just so many other pairs, as opposed to this one. There's these gaps here. There's nothing in there. Only these ones are part of this relation, which is not a function. Okay, everybody?
Yeah.
On board, other than the few people responding with? Everyone in the room, Basar, Che, Patricia, Elcida, Gumru, Jorat, Marta, Rafaelina, Raquel, Robin.
Yes, I'm here.
Is everyone on board? Any questions, everybody?
No question.
No, no question.
Please let me
No
know.
questions. No question. Did you do attendance, Professor?
We'll talk about the attendance. Let's talk about the class now and we'll get to the attendance. Okay? Again, these are not too complex to understand. If you understand them, you can answer them in seconds. But let's say you missed class or you didn't pay attention or something, this may seem like it's so complex, but it's not. As you can see, we answer these in seconds. That's intro to functions and relations. Let's see if we have any other cases. We have, please mute your mic if you have background noise and noise from a microphone. Touching it or hitting it, it's making an annoying noise. One thing, another thing I believe we need to talk about before we move on. We're actually going to do that when we start a new topic called the function notation. So in our next class, we're going to talk more about functions. We're going to introduce the infamous f of x. So there's that. We're going to talk about it in detail. This is basically the foundation of that. And we talked about it like this. But next time, we're going to actually say the notation of it and how to actually write functions and how to read them and how to graph them. So that will be the subject of our next class. Let's see. Yeah, another thing before we end this class today. So we saw stat notation. Now I'm going to introduce another notation called, or another term called domain and range. This will be number 4. So domain and range of a function or a relation. Let's take this table here, X and Y, whatever that X might be, could be ages, students, IDs, whatever. And let's take a few things here, A, B, C, and D, and possibly put some values here. -2, 1, 5. And let's do something like this. Okay, so we have this table here. Few values here, few values here. We want to determine the range and the domain. It's very simple. The domain is the first column, okay? And the range is the other column, the other values together. So to write this, say domain or D sometimes. Then you open your curly braces as we saw earlier. This is again instat notation in this form. You need the name, colon, curly braces, and all the elements inside. So domain, colon, open the curly braces. What are the elements of the domain? Or the column X?
D,
X.
The elements of X are?
A, B, C, D.
That's right, all of them. Just separate them with what? Separate them with comma. A, B, C,
D.
and D. That's it. If we said, what's the domain of this relational function? Very simple, just write those together. What about the range? The range is?
-2,
Negative
1,
2.
and 5.
Exactly. All these numbers, usually we arrange these from the lowest to the highest. Okay, if you have numbers or letters that you can arrange, always do them in an order. For example, here, what is the smallest one?
-2.
-2, then, comma,
1.
1, and
5.
5. That's it, done. So domain and range. It could be like this, or it might be, this might be in the form of a set. Let's say, you may have a set like this. Some random set 1, with some values. Let's say 2, 4, 7, and 4, -1 and 0. Now, first of all, that's good. We answered the question domain range. By the way, is this a function or not?
Yeah.
Why not?
It is.
It is a function because each one has 1. B has 1. C also has 1. D also has 1. No, in other words, no student with 2 things. Here it's okay because 2 students can share the same age, okay? Just be careful that one from here cannot have 2 from the other side. That's the definition we saw earlier here. Each element from the left column corresponds to exactly 1 element from, or value from the Now this next example, let's get the domain and range of this set. So domain D, colon, curly braces. What are the elements of the domain of this function? Is that a function first?
Yes.
It is a function. Nothing is repeated. We have 2, 7, -1. All unique, distinct elements or values. What's the domain?
2, 7, and -1.
Which one we start with?
-1,
Comma.
2,
7.
7. As the domain, then the range. What is the range here?
0, and 4.
4, 4, and
Right? We have 4, we have 4, we have 0. The good thing is you don't have to repeat that in the domain here. You just have to write 4 once, but we have 0 here, so the 0 should be first. We have 4, 4, 0, so 0 is the smallest, followed by 4. Again, no need to write the other 4, just once. Once is enough. We want this to be unique and distinct. Okay, so that's your introduction to functions. I know this was a lot of new terms. Okay, a very important introduction. And the next, I would say, 2 or 3 classes will be based on this. So it's very important that you understand this. Please rewatch this. I'm going to post it. If you still have any ambiguity or any confusions, make sure you understand each term that we talked about today. And let me know if you have any questions in our next Zoom meeting. Because that's, again, very important. If this doesn't make sense now, I'm sure it does for all of you right now. If it doesn't, please let me know. If this doesn't make sense, the future stuff may not make sense as well. And these are not complex concepts to comprehend. Like I said, once you understand what you're doing, you can answer the questions within seconds. So let's recap what we saw today. So we saw what a relation is, function. Make sure you understand those. This is the difference between the two. You can tell easily from the graphs. I mean, from the groups or tables, also from set notations. Then the graphs. Just remember the vertical line. If it meets once, good, function. If it meets more than once, not a function, not good. One student has one thing. One student has two things or more, not good. Okay, so that's graphs and functions of relations. Finally, remember the domain and range. So the domain is the column on the right or the first element, and the range is the second column or the second group if you have groups like this. So this is the domain, this is the range. So if you're asked to write them in set notation, let me add that here in set. In set notation. So domain, range, set notation. This is what you do. Just take the elements. You don't have to repeat them. Just write all of them. Don't forget the name, the colon, very important, and the curly braces. Again, not the brackets, not the parentheses. Might be a little difficult to draw this curly brace. I don't know if it's that difficult. Just try to do a bracket, maybe a little circle here or something. Okay, if it's that difficult, if you can't do this, that's fine. Just do this, a little circle in the middle, and you have your curly brace. And okay, so curly brace, list all the elements or pairs with commas, don't forget to close. So this is what we mean by set notation. We have a not notation we're gonna talk about in the future, but for now, this is good enough. So all these terms and new concepts, please understand each one of them. If you understand this, the future classes will be much easier, will make a lot more sense. Capiche, everybody? Everyone in the room?
Yes.
All good?
Yes.
All right, so again, always ask, please. If you don't say anything, I assume everything is fine. So it's time to ask, or forever do what? What is it? Complete the sentence. You can ask now or forever hold your.
Hold your peace.
Exactly. Okay, always take the initiative, ask and everything. Don't hesitate, please. Don't be shy. Don't feel intimidated. Everybody's here to learn, so it's not taboo to learn or to ask questions. Please take advantage of all the circumstances and learn as much as possible. Well, everyone is here to learn, so I'm here to help you out. So please feel free to engage and ask anytime. Okay, I believe I've talked enough for the day. Any other issues before we move on to other things, some attendance and some lesson plan homework? Everyone? No questions? All right, so that would be the lesson for the day. Again, I'm gonna post this lecture very soon. Rewatch it. I recommend everybody rewatches this. You know, it was a few terms. Get familiar with those and understand them very well. Again, that will make your life a lot easier in the future classes. So let's take some attendance.